So next up, we're going to continue with the theme that I talked about earlier around compliance and security, and bring up NIST, C2 Labs, and Andrew from Docker back on stage to talk about the NIST OSCAL standard that Aiden mentioned earlier in his talk. And so with that, I'd like to introduce David Waltermire, who is the lead standards architect for security automation program at NIST and a significant contributor to the National Vulnerability Database, Security Content Automation Protocol, Continuous Monitoring, and other security automation projects. Anil Karmel, who is the CEO and co-founder of C2 Labs, formerly of the National Nuclear Security Administration, Deputy CTO. And of course, Andrew from Docker, who's going to help with the demo. So with that, I'm just going to kick it over to these guys.
All right. Great. Good afternoon. And we realize that we stand between you and a drink of your choice. So hopefully this will be somewhat interesting and engaging. We're going to talk to you about, in the vein of standards and compliance, automating security and compliance via a new standard of standards. So the Open Security Controls Assessment Language. So we're going to start with a high-level overview of what that really means from a standard of standards approach. We'll then step into a technical presentation that will be led by the technical lead of the project, David Waltermire, and then you'll actually get to see OSCAL in action, where Andrew will give a demo of what that actually looks like. So as opposed to just hearing what it is, you actually get to see what it does. So with that, let's start with a high-level overview. So why OSCAL? So information technology is complex. The reality is we have a myriad of different information systems that we are responsible for certifying and accrediting, and they don't all necessarily live on-premise. They live in cloud service providers. They live in a variety of different environments, and we have to ensure that they are secure and compliant. These security vulnerabilities are everywhere. 0 days come out on a daily basis. How do you stay ahead of the next 0 day, right? Coupled with the fact that you've got these regulatory frameworks that you have to comply with, 853, PCI, HIPAA, ISO IEC 27001, COBIT 5. You name the framework, there's a variety of different frameworks that have a variety of different controls, some of which can be mutually exclusive that yet, if you're a cloud service provider or whatnot, that you have to adhere to. How do you manage risk in this environment? Risk management, we have great frameworks, which is fantastic, but how do you really quantify what that risk is to those workloads within your environment? And then last, but definitely not least, the documentation that you generate to validate that your workload is compliant is out of date the moment that you write it, right? You have lots of people that are writing these documents that as soon as it's written, a change comes out, your information system, the document's out of date. So those are lots of the reasons of why you do a project like this. So what is OSCAL? So what OSCAL is, it's a standard of standards that normalizes how security controls and corresponding assessment information are represented. So there's 3 key components of that model. From a standard point of view, it provides security controls, control implementation, and assessment information in an open standardized way for both machine-readable and human-readable format. And you're actually going to see what that looks like in Dave's technical presentation of the standard, as well as what that actually looks like in action. It's got to be interoperable, right? So the standard has to be well-defined so tools that use that information can use that information consistently across different standards, right? Different control catalogs, as well as on the target applications. And it's got to be easy to use. It can't be so complex where you don't know necessarily how to use this. So you have to have an easy-to-use standard that is easy to understand and easy to consume. The end goal being to improve the efficiency, accuracy, and consistency of system security assessments. So what are some of the benefits from an OSCAL point of view? Well, if you're an operations person, you can rapidly verify that that system can be compliant against your organization's security requirements, right? If you're a security and privacy individual, you can identify those problems from an automated point of view and address them before loss or damage occurs. If you're an auditor or an assessor, right, you have the ability by leveraging this type of approach to conduct those audits and assessments on demand as opposed to coming in with a team of folks to try and do this work, right, with minimal effort. If you're a policy individual, you can identify these systemic problems that will then drive changes to your organizational security policy. And at the C-suite, right, via these OSCAL-enabled tools, you can now quantify that risk to your information system, right, suggest remediation actions, and then dynamically generate this type of documentation on demand. So from an approach standpoint, these are the reasons why you would want to leverage a standard of standards, right? So the goals of the project are to have these OSCAL-enabled tools, right, both existing and new tools, and OSCAL formatted content widely available, right? OSCAL will enable that decrease in assessment-related labor where you don't have a bunch of people that are trying to assess the efficacy of your information system, right? And you'll be able to assess that security far more frequently, right? Ideally, continuously, right? Driving that continuous compliance approach, right? And then you can assess that against several sets of requirements simultaneously. This is not just for 853, right? In as much as for those of us that support the federal workforce, 853 is front and center in our minds, but for those that support healthcare, HIPAA, right, financial, PCI, it's got to support all of these different standards, right? And then having a consistent performance of assessments regardless of that system type. So with that, I will hand it over to Dave to conduct a technical presentation of OSCAL.
Great. Thank you. Thank you, Anil. So I'm going to be giving a fairly rapid overview of OSCAL. We'll have some time for questions at the end. So if I didn't cover a topic that's interesting to you, feel free to speak up at the end. So today I'll be talking a little bit about what we're currently, what we've developed with the OSCAL project. I'll be talking about the problems that we've solved. I'll be talking a little bit about what we're working on now and where we're going. Before I get into the technical bits, I wanted to talk a little bit about some basic terminology that we use in the OSCAL project. So there are three terms that we typically use. The first is control, the definition that I provide here is out of NIST SP 853, but it really applies to controls from multiple control catalogs. It's a safeguard or countermeasure designed to satisfy a set of defined security requirements. So in OSCAL, we're dealing largely with controls and control-related information. Catalog. So a catalog is really a set of those control definitions. And in OSCAL, we're dealing with, our work has really evolved around three kinds of control catalogs. We've got NIST SP 853. We've been doing work with ISO 27001 and 2, and also with COBIT 5. One of our goals for the OSCAL project is not to come up with a point solution that works well for 853 to the exclusion of other control catalogs. We want to come up with a solution that will help to begin to bridge the gaps between the various control catalogs that exist out there. And then profile is the final term. So a profile is a set of security requirements. It's often referred to as a baseline or an overlay in various parlances. And so examples of a profile in OSCAL are things like the 853 low, moderate, and high baselines, or the similar levels of baselines that FedRAMP has produced. But it can be really any subset of controls that an organization defines as a set of security requirements. So with that, I wanted to talk a little bit about the work that we've been doing. So our current focus has been around developing a data format or multiple formats that will actually support defining catalogs and profiles as well as frameworks in a structured way. And really what this is designed to avoid is what I would like to call a spreadsheet hell, which I think a lot of us end up dealing with on a day-to-day basis. So how often have you looked at a document that describes a set of security controls or a spreadsheet and kind of scratched your head and said, I don't understand specifically what this is trying to convey? I mean, there's just a lot of ambiguity out there. So what we've been trying to do in OSCAL is to develop a structured semantic model for describing control catalogs using a common model and control baselines or profiles using a similar kind of common model, as well as defining a model for frameworks. So what we're calling a framework is something like PCI or HIPAA or the NIST cybersecurity framework, things that map into low-level vocabulary of controls. So we're trying to tackle that problem as well. In OSCAL, a catalog is a collection of controls. A profile defines a set of requirements based on those controls. So in our current scope, we've been working to represent 853 information using the OSCAL catalog model. And in a moment or two, I'll be showing you some examples of those. We also have some structured representations of profiles also represented in OSCAL, which allows you to identify controls from multiple control catalogs in a single profile. And the profile model that we've been developing allows an organization to effectively customize the controls. So you can do things like add new controls, add statements to existing controls, set parameter values, things like that. So the idea is that by providing a common data format, we support a number of users that are working with control information. So we provide a format that catalog maintainers can publish control information under. We can allow for those catalog providers and third parties to provide standardized profiles, like FedRAMP as an example, using OSCAL. And we can support tools that can then ingest this information and use it as part of their assessment methodology. So no longer will you have to go through a spreadsheet and enter a whole bunch of information into a console. You can simply represent that information in OSCAL, import it into your favorite tool. Which then supports a lot of downstream end users, folks that are doing operations, security and privacy, that are conducting audits and assessments, and defining policies. So the previous gentleman was speaking about the RMF. OSCAL really in its current state supports the selection, and we're working towards supporting the assessment of security controls. So here's an example of an OSCAL catalog. This is kind of a stripped down example. So this is an XML representation of OSCAL. We also support a JSON-based representation. So within a given control, OSCAL allows you to represent the title of the control. You can provide statement text that is structured to describe the specific requirements of the control. You can embed parameters into that text, and you can define those parameters in a way that the values for those parameters can be assigned. And it includes other supportive information like document references. This is an example of an OSCAL profile. So as you can see, this profile is importing the 853 Rev4 catalog, and it's selecting a bunch of controls within that catalog, establishing a baseline. It's also selecting some control enhancements, which we call subcontrols in OSCAL. So that's where we've been currently working. Our plan is to continue building on the foundation that we've generated with OSCAL. So the idea of taking a bottom-up approach is to provide something that's completely useful to an OSCAL consumer as we work on providing more and more functionality. And so the reason we started with the catalog and profile schemas is this is something that can help to reduce spreadsheet hell for a lot of organizations that are struggling with that. While we start to work on building the implementation layer, which is really about helping an organization understand or to document how they're implementing a set of controls, and then the assessment layer, which will be used to support more automated assessment of security controls and systems. So the plan going forward is to work on defining how a control is implemented on a system, how controls are applicable to a given system, defining how a control on a given system can be assessed. So the idea that we're thinking about right now is allowing vendors to provide data about how to assess their products, and then using that data to then automate the assessment. So we've already started working with the open control community in this space. We have a number of participants in the OSCAL team, like Andrew, who's been participating in open control. So at this point, as a team, we've been working to understand the work that has been going on in open control, and we've been working to align the work in OSCAL to make sure that that what we're creating can be usable within that community. And so as we're working forward on the implementation layer, we'll be considering that work and trying to merge those efforts together as best as possible. So our long-term goals for OSCAL are to enable a significant decrease in assessment labor. So we're going to do that through structured data and automation. We want to allow an organization to assess a system's security controls on a regular, ongoing basis. So effectively, our goal for OSCAL is to allow for continuous assessment of security controls. And to allow an organization, through being able to map controls across control catalogs, to assess their system's compliance with several sets of security requirements simultaneously. So an organization that has to deal with HIPAA and PCI and financial regulations that have underlying control catalogs can basically do a single assessment that can map across those. And to be able to do this in a platform-neutral way. And from that perspective, Andrew has actually been doing a lot of work around setting up some of the basic capabilities to assess a platform.
Thanks, David. Just get set up here. Yeah, so the OSCAL effort is really excited us at Docker. As you can see there, make sure this doesn't slide off. Really the key focus around OSCAL is automation and being able to represent artifacts in a machine-readable format. And if you think about the way that Docker has been built and has become popular, it's really based on this core set of command line-driven, API-driven tools to allow for containers. But if you think about the way traditional security processes happen in regulatory environments or highly regulated environments like FISMA, like PCI, like HIPAA, how do we actually map container technologies, which are much more ephemeral and dynamic, into these models where we have to go in and we have to go through these arduous paperwork exercises to do that? It's a little bit easier to do it when you have a stagnant system, so you can go into VMs, you can pre-provision that architecture. But with containers, it's just a lot more difficult to do. So one of the things that we want to announce today is that we are fully committed to supporting the OSCAL specification. We're helping to develop some of the JSON artifacts for the OSCAL specification and also additional tooling as part of the OSCAL specification. So for folks that are developers or working on the command line or building software today, we've also been developing an SDK. We'll be open sourcing that SDK under the open control community for folks to consume and use. I mentioned just now that OSCAL in its automated approach and machine-readable approach is really well aligned to the properties of containers and the value properties of containers that are provided. So no longer do we have to worry about these arduous assessment exercises. With OSCAL, we have the ability to automate those pieces with container technologies. Of course, OSCAL aligns nicely with regulatory requirements, and we can do it across different verticals. So of course, many folks in here today are focused on FISBA compliance, but we're working with some of the largest financial and healthcare entities in the world today who have PCI requirements and HIPAA requirements. And we now have a single standard by which we can provide for compliance artifacts and automation across the board, and even for organizational specific artifacts. So if you use a subset of a standard or multiple standards within your organization, you have a single way or single mechanism to be able to do that today. And of course, we're helping to shape the way that existing standards are developed, or helping to provide guidance on how existing standards can be modeled to apply to container-type technologies. There's been a new set of publications that have been released courtesy of some of the other NIST folks in the room. The 800-190 series is an excellent guidance document that was developed in partnership, or Twistlock and NIST worked really diligently on that document. Other things we're trying to do is we're helping to provide you all guidance in how do we align existing mechanisms today. So how does RMF map to container technologies? How do we define authorization boundaries for a dynamic subsystem or net-centric architecture, which is the official definition? I've been doing my research, David. I just got CAP certified, or certified authorization professional. So one of the first things we needed to do is before we can make any of these guidance recommendations, we have to better understand your requirements. And that means working with you all into the ATO process, getting that type of feedback so we can give you guidance for helping to define some of these terms in the realm of containers. And of course, as Banjo mentioned earlier in the presentation, we also want to deliver one of the first OSCAL-ready container platforms on the market. And that means that out of the box with the enterprise platform, we have support for ingestion and creation of AAscale artifacts. We'll give you a little bit of a sneak peek of that, and I'll caveat that in a second. We'll give it a little sneak peek of that today. Later on this year, you'll see a little bit more about that at DockerCon and see more of this uncovered throughout the year as the OSCAL specification matures. And of course, we want to enable continuous compliance for all those standards and for all the different workloads that we want to address or are already addressing, as Banjo talked about in the keynote earlier. So we want to bring compliance to your traditional applications, or I should say automated compliance to your traditional applications, microservices architectures, ISV apps, big data, serverless technologies. Now we can do that with a single standard and a single specification, all built into the stack. So what I'm going to do is I'm going to show you a couple of things that we've been working on. What I have here is just a terminal session. Everything's going to be command line driven today. You'll hear more about some of the UI developments that we'll have available later in the year. But one of the first things I mentioned is you want to build across or on top of a secure platform. So I have a Linux host that I've deployed in my environment. You can see that I have FIPS mode enabled on this host. So of course, one of the core requirements, mandatory requirements in the FISBA space, is I need to adhere to FIPS standards that are out there today. Of course, one of the big ones is FIPS 140-2 for cryptography requirements. So we want to make sure that we deliver a secure container runtime that also adheres to those standards. So one of the things I have here is a build of the Docker Enterprise Engine. And you can see here, it's a little bit small, maybe easy to miss for some folks. But you can see that under our security options, we have the FIPS mode enabled. So today what you're seeing is the first and only container runtime on the market that has FIPS mode enabled out of the box. And this is operating system agnostic, meaning I can deploy this engine on a number of different operating systems out of the box today that also support FIPS mode. So you don't have to rely on any sort of specific wrapper around that stack to get those types of capabilities. Oh.
Great.
Yeah, so could you give a little bit, thank you. Could you give a little bit of a definition of what FIPS enabled means, i.e., do I have to have a base operating system which is FIPS certified? Do I have to have a chip that's FIPS certified? How deep does that go?
Yeah, so Docker itself ties into the kernel features provided by the operating system, at least in Linux, and then analogous features provided in the Windows world. The key is you want to make sure that you're deploying on a distribution of Linux that also provides for FIPS validated modules. And those are special cryptography modules that have undergone NIST validation processes to meet certain cryptography requirements. And today, the enterprise stack has been designed such that it's only deployable on a set of enterprise-supported Linux distributions that also provide for those capabilities. So what I mean by agnosticism, it's not running Docker on a non-FIPS possible host, but you also want to still be running on a FIPS possible host to truly satisfy that requirement. And that also passes into the container technologies themselves. So these FIPS capabilities are also bubbled up into the swarm mode stack for deployment, and will also soon be bubbled up into the Kubernetes pieces that we wrap into the stack as well. Hopefully that helps. And if you don't believe me, this module is currently in process through the NIST cryptographic module validation program. And this is unique to Docker in that this is the only container runtime today that has this specific module and this specific module in process. So it's not dependent on a third-party wrapper to provide. So I mentioned we want to make sure that we're building on a secure platform. The next piece is, all right, how can we actually bring OSCAL into the picture and actually provide for some of this type of automation? So one of the things I talked about is, how do we start to define authorization boundaries? So the first thing we need to do is we want to make sure that our system itself can be audited against any number of control catalogs. And with OSCAL, we can do that today. So one of the things we wanted to do was, instead of relying on a third-party tool that you would have to depend on and learn how to use and inherit, why not let the system itself be responsible for those auditing capabilities? Why should I have to worry about relying on all these things when my system can automatically be audited against these policies and also enforce these policies on demand for both traditional standards that are out there and maybe custom catalogs and controls that I've defined in my environment? So what I'm going to show you here is this is very much a minimum viable product. This has not been made available. I don't have any hard timelines on this, and the actual end capabilities will probably change. But this will just give you kind of a taste as to what our goal is with the OSCAL specification. So what I have here is a deployment of the Docker Enterprise Stack. This is the latest release, soon to be latest release with the built-in Kubernetes support. And I have a set of backend services here, which we denote as our OSCAL proxy service. This is a system service that runs itself in containers and allows for consumption aggregation of the OSCAL specification. And as you saw David get a preview of, it's merely just XML and JSON, which we can easily consume and parse. We love JSON, and that's what we've decided to consume as part of the spec. This proxy service is made up of a couple of different subservices, again, that all run in containers. And you can't see them here because we've hidden them as system services. But one acts as an API front end. One acts for some simple key value storage, so I can retrieve my artifacts on demand. And one acts as the central aggregation service. And this is a preview of that API being served today. There are a couple of different API endpoints that we've developed. We want to store these artifacts that we generate securely, so we can store them in Docker secrets, if you're familiar with Docker secrets, amongst a number of other backend artifacts. The other thing we want to do is, oh, we got a question? Can you zoom in? Oh, sorry. Yep. The other thing we want to do is we want to make sure that Docker, the stack itself, can be validated and audited against any number of security control catalogs. So you can see here that these are the catalogs that today I've enabled for my system, and also profiles that I've enabled for my system. Furthermore, not only are we restricting ourselves to 853 controls and profiles built on top of that, like the FedRAMP profiles or maybe the DoD SRG's impact levels, but also maybe catalogs like CIS benchmarks, or maybe custom profiles or custom catalogs that you as an organization have developed. And then, of course, I want to do automated reporting against my stack. And these are simple API calls that I have available as part of this. So in a report, and this is not the final OSCAL specification for the assessment pieces. This is just kind of a subset of a sampling that what would be generated. But you can see that I want to make sure my cluster state is healthy per a specific regulation, which in here we've defined as FISMA. With FISMA, we want to satisfy 853 controls, maybe amongst a number of other requirements. And for this particular case, I'm deploying the stack in a FedRAMP high mandated environment, or my baseline that I've determined for my system is a high FedRAMP high baseline. And then, of course, for all of the different control families, we want to make sure we satisfy a percentage of controls that's applicable to our application stack. And you can see here that I've satisfied 51% of the access controls, 81% of the audit and accountability controls. These numbers are arbitrary. These are not the exact representations. But going into here, one of the things that we've been working through is why not have an easy way to run commands out of the box with Docker. So using the API backend pieces, we've prototyped the Docker compliance command. And the Docker compliance command today has a simple subcommand. It's an audit command. Eventually, we want to support automated enforcement and so forth. And we want to audit against any number of profiles and catalogs. In this case, the ones that I've enabled for my system are FedRAMP high. And if I run the command, you'll see that with OSCAL behind the scenes, we can automatically associate FedRAMP high with 853 catalog. It initiates a validation, and pretty quickly, we validated the system. And I know this might seem like a bunch of gibberish, because this is output that, again, this is not the finalized OSCAL output, but this would be an OSCAL formatted output that represents my system. But with OSCAL, we now have a machine-readable format that we can do our auditing with on reporting against. It's a standard format, and it's all just XML and JSON. So we can do some interesting things with it. So if I refresh my reporting view here, I can do things like create a web-based slideshow, which is kind of a sample FISMA audit of my system, just with a simple command. And I could generate just a nice view of, here's my access control family, and here's the system-specific controls that I've satisfied, and here's a percentage of those controls that I've satisfied. So again, this is not the final UI. This is not the direction we're probably going to end up taking any sort of UI. But this just goes to show you the flexibility that you get with OSCAL in a machine-readable format. Again, let the system take care of the auditing for you. You can see that with a simple command. All I typed in was FedRAMP high. It had automatically knew which controls to assess. It automatically knew which checks Docker needed to do. And furthermore, these are not just system-specific controls, but also notifications that me as an ISV can correlate with the control requirements. So if we don't fully satisfy a control, if you need to depend on maybe an Active Directory configuration, we'll say, here's what Docker can do, but oh, by the way, here's something else you should look at to further satisfy the control. Because again, we're not the ultimate responsibility in the system authorization. That's the responsibility of your risk assessors and your AO ultimately. But we want to get you most of the way there. And furthermore, we view this as a way to wrap specific application stacks and audit them and enforce policy for them in a prescriptive manner. And you can do so all with a standard format. So we envision a day where you can do a Docker compliance for a stack or a Docker Kubernetes compliance, which automatically wraps those resources, and you can automatically get an auditing and assessment report that satisfies the OSCAL standard. So with that, I guess we'll leave it with any questions. I will actually show just briefly here what OSCAL looks like. And again, it's just a simple set of XML. This is a FedRAMP high profile. And this is the JSON that we're consuming, which is the equivalent. It's really flexible. You don't, as a day-to-day security and audit professional, ever really have to look at it. You can let the system do a lot of those services for you under the assumption that vendors and other providers will support the specification.
So this is the XML representation, or this is the JSON representation of a profile. And that's, I showed you earlier the XML version.
Yep.
We support both. They're effectively equivalent models between the two.
Any questions?
All right.
I think maybe we have one.
Gideon?
Oh, yeah.
So this might be getting ahead of things a little bit, but in the metrics and the sort of like proving that compliance was met, certain levels of access are needed, like to check the Active Directory configuration or what have you. And so I'm wondering if you've thought at all about how that might work, where is there a central collector that just has kind of super user privileges that can do all these checks, or are there different ways that can be handled?
I doubt that we'll end up actually defining any rigid requirements in OSCAL around that, just because we're going to want to provide for quite a bit of implementation flexibility, because different environments are going to have different security levels, different sensitivity concerns that they're going to want to address. The one thing I could tell you is that we want to. The key to automation is to use existing tools that are available within an enterprise and instrument those tools. So we would likely be looking at leveraging existing services from tools to actually ingest that data. An OSCAL-enabled tool would have to authenticate with that service, probably.
Yeah, so it all really comes down to, you have a standard that the tool can then leverage, whatever tool of choice makes the most sense within your organization, right? To then ingest and present that information to you in a usable manner. Any questions on the demo? And then we have the contact slide we can put up if you have any questions.
If you could go back to the question slide, too.
Yeah, exactly.
We can go back to the slides.
Yeah.
So is it basically just an ontology, and two software tools will use this as standard? Is that the concept? I
Yeah.
don't mean just an ontology. That's difficult to come up with. A good one.
Yeah, so
Basically what it is?
Right. It's a rich semantic model for describing controls and assessment-related information.
right. And another piece to that is, the way that controls are expressed today in PDFs, right? They're expressed in a variety of different ways, right? Yeah, so standardizing how those controls are represented in a standard model, right, in a standard schema, allows tools to leverage that standardized model to present that information back to a user, whether it's presenting it to a machine or presenting it back to a user in a useful manner.
Yeah. So we were having a GitHub discussion about IDs and addressing and that sort of thing. So one of the values actually in providing a more structured, more well-defined form for this information is we now have things that you can count on and reference, like IDs within the format. So, I've seen 100 different ways of representing an 853 control by name. Is it lowercase? Is it uppercase? There's so many different variations. Within an OSCAL catalog, there is a definitive ID, for control, and these are things that you can then reference from other places. So, by building up this kind of semantics and structure, we allow for more advanced machine use cases with the information. And having a clear understanding of the semantics of the information, further enables more automation, more machine understanding. Greg, you had a question.
I did. And I guess disclosure, I'm very supportive of this effort. So when this comes forward, right now, because NIST controls the 853, it would be possible for NIST to publish an OSCAL compliant XML or OSCAL compliant data file for 853. But I guess my question is who publishes the OSCAL compliant version of PCI and other standards? And then extending on that as a second part, could you outline, if I wanted to use OSCAL in my organization, and we assume that all the pieces are in place, if I was doing it, what pieces do I have to have in my organization in order to take advantage of OSCAL? So, two-part question.
Yeah, I think I could take the first part, and maybe the others could take the second part. So, your first question was really around who creates OSCAL content.
For the catalog.
Right.
Just to the catalogs.
But it's a broader question too, though, about profiles and baselines and that sort of thing. So the idea is that we want the authoritative organization that produces the catalog to produce the OSCAL content, because they know the most about their catalog. They can most accurately represent that information. So NIST is doing that for 853. ISO, SC27 maybe could do that for the 27001 and 2 information. COBIT, PCI. We would expect that those organizations would actually provide catalogs and profiles using OSCAL. And then for profiles, it's the authoritative organizations that would be developing the profiles. So, NIST produces the low, moderate, and high baselines, so we're producing OSCAL profiles for those. FedRAMP is producing baselines for their use. We're actually starting an effort to work with them on producing FedRAMP profiles for those baselines. Organizations may customize those baselines. One of the things that you can do in OSCAL profiles is you can reference an existing profile and then customize it. So organizations will create their own authoritative baselines based on their own needs. We're expressing the requirements for how you represent the information, and we're expecting the organizations that actually produce the information to use that form. And then we had the other question about what sort of mechanisms, capabilities are going to be needed in order to support OSCAL within an enterprise environment. So why don't you guys take
so
this?
That speaks to the other side of you've got content producers and then content consumers. You need the right tools, right? So it's going to come down to having OSCAL-enabled tools, whether new or existing, that take this standardized way to represent that information and then produce it in a useful manner, right? So Docker, for example, and Andrew just gave a great demonstration of OSCAL in action, of how Docker is using this type of standard to drive security and compliance of the platform and demonstrate what that means by executing a single command, right? With more to follow at DockerCon.
We can share more after because we're tight on time.
Yes.
So thank you. We apologize for the hiccup.
Yeah, sorry, we're actually...
Okay. So one quick question. So so you guys said that you're publicly announcing, I guess, next week.
Next week.
So these links, I was just trying them out real quick. It looks like they're 404s now, so I guess they're going to be publicly released with that.
Yes, actually, I was going to mention that at the end, so thanks for keeping us honest on that. So we're launching the pages.nist.gov/OSCAL site tomorrow, and we'll